Hello everyone. Today we've got a fun little project, especially for all you barbecuing enthusiasts. We are going to be installing little LEDs in our barbecuing knobs. Now, why would you want a LED in your barbecue knob? Well, this comes out of necessity from my absent-mindedness, or perhaps too many wobbly pops during the barbecue, but I have often on occasion, quite embarrassingly, left the barbecue turned on for many hours afterwards, even sometimes overnight. And despite the obvious fire danger that presents, you're just wasting money, right? You wake up in the morning, your propane tank's empty. If you're plumbed into natural gas, you've just wasted a ton of money that way. And this is essentially, like I said, an idiot light that comes on whenever the barbecue knob is turned on and gas is flowing, and then it turns off in the vertical upright position of the knob. We can see our barbecue fine from outside, or from inside the kitchen looking out, except I can't tell which way the knob is oriented on the barbecue. I can't tell when it's on, low, high, off. These used to have little black dots on them. They've worn out. But even with the black dots or the red dots, I've seen some of these with red dots, I can't tell. I can't see from the kitchen. You know, it's 30, 35 feet away. So this I can see from 100 feet away plus. And it's a really simple little project. 4 very cheap parts that you need for each knob. You have to make one of these for each of your knobs. So if you had 5 knobs on your barbecue, you'd be making 5 of these. I'll just go over the parts real quick. We've got LEDs, of course. That's our little light source. I'm going to link to all these parts in the description below. This little set is kind of neat because it gives you five different colors: red, yellow, white, green, and blue. So you can use whatever color you want. I chose blue because, you know, natural gas or propane, blue flame made sense to me. I like using the 3mm. These are the 3mm LEDs over the big 5mm. Again, up to totally personal preference, but I found the little guys perfect. I like using diffused, and I would recommend using diffused for this project because, one, clears are so harsh. I just find them just annoying to look at. They really bother me. And the other problem with clear is they're very directional. They point out very straight. There's not a big dispersion of the light pattern. Whereas diffused, you know, the whole top of the LED kind of lights up. So you can see it at, you know, a rather acute angle as well, which is perfect for this application. So again, recommend diffused if possible. The other little thing we've got here is a mercury switch, a little micro mercury switch. This is what, these are also known as tilt switches. And in this situation, in our application, we're tilting the knob, and that's when the light lights up. And all these are, it's a little glass vial with a little bubble of mercury in it, and when it tilts, the little bubble of mercury, which is electrically conductive, contacts these 2 little pins and closes the circuit and turns the LED on. It's that simple. We're powering this circuit with a 3-volt 2032 button cell. It's very important that you use a button or a 3-volt battery. 1.5 volt button cells aren't gonna have enough voltage to drive these LEDs, but 3 volt is fine. And you don't have to use a current limiting resistor, which is again why this is such a simple little circuit. No current limiting resistors needed. You can drive the LED direct off the 3-volt button, no problem. Why I chose a 2032, because you can get smaller 3-volt buttons, but the smaller the cell, the more often you're going to have to be replacing them because you'll be draining the battery. LEDs use so little power as it is, but the longer you can go between battery changes, the better. 2032s are also dirt cheap online now. I picked up 50. I can't remember what I paid, but I've got a lifetime of button cells now for my barbecue. And as far as life, I've had this project going in my barbecue for just over 6 months now. They're still all really bright. I haven't had to replace a button cell yet. Of course, it depends on how often you barbecue, but I would think, you know, 4 to 8 months if you use your barbecue several times a week is about the norm. If you barbecue a lot more often than that, you're just going to probably be replacing cells a little bit more often. I also found the 2032 was a lot easier to find these battery cases for, and that's the fourth part. You need these little 2032 battery cases to hold the battery inside the knob, and then it makes changing them out really easy when they do go dead. The knobs themselves, these are the ones that were on our barbecue. I think this is a very generic type knob that I think quite a few barbecues use, even when you go into the store and look for replacement knobs. These are a very common one. They're a chromed plastic knob. They've got these reinforcement ribs in the four quadrants around the center square section. What I've done on mine is I cut the one rib out on the top. That's where my LED is. If you wanted your LED at the bottom, you'd have to cut the bottom rib out. But I cut the top one out, and that's so you can fit the LED dead in the center where the rib would be. You could have the LED off center if you wanted to leave that rib in, but you wouldn't be able to fit your battery holder in. I'm just gonna, here's one of the little case circuits I've made, and yeah, it just fits in there. And you see, you need that rib out of there for all these little components once you've got them soldered together. I have seen some commercial grills, some other ones with knobs. Let me just get this going. What they've done is they've actually put the LEDs shining back. They're back out of the back of the knob, and as long as you've got these shiny chromed bezels, oh, is this going to be difficult for us? Of course it is. So we can just get that to give you an idea of what this would look like. Anyways, the idea behind this, if I ever can get it to work, is you've got this really neat backlit effect if you do it this way. Problem is, I wanted to see this in the bright daylight too, and I found this backlit effect I couldn't see in the daylight. At night, of course, you can see it, so if you're primarily barbecuing only at night, this is a really neat effect that you might want to try. You might want to put in two LEDs in opposite quadrants to have enough light coming out. And this is where you could actually use the clear ones, because they'll just be a lot brighter, but whatever. It's a neat effect. Didn't work for my application, but if you want to try that on yours, it's super cool. The way the circuit works, I'm just going to show you one here. We've just got the LED wired to the battery case, and negative to the battery case, negative, positive to our mercury switch, and then the other end of the mercury switch to our positive on our battery case. And again, as it tilts, light comes on from just off center all the way to low, and then off again when we are back in the vertical. I'll just let you look at this so you can kind of get my spacing. That's the only kind of hard part about this, is just getting everything spaced out correctly so the LED fits in the knob, the battery case is in the right position, same with the mercury switch. So this is just how I've got mine configured. And the neat thing is, I didn't have to trim any of the leads off the LED or the mercury switch. This is all just straight, not trimming at all. 3 solder connections, one on the negative of the battery case, the other LED lead to the lead on the mercury switch, and then the mercury switch to the positive pin on the battery case. And it's that simple. So no limiting resistor needed. You don't even have to cut down any of the leads. Should mention one thing with LEDs, stands for light emitting diode, meaning they're polarity sensitive. A diode will only allow current to pass in one direction. So if you hook these up backwards, if you solder them into the circuit backwards, they won't light up. It's not going to damage the LED hooking it up backwards, it just won't light. So you have to have positive to positive, negative to negative. Easy way to tell that on LEDs is your positive lead will be your slightly longer one, and the short one slightly shorter. Well, that's your negative. So when you solder these onto the case, this is the short lead, to your negative pin on the case. Positive again goes to your switch. And I think that covers everything. Oh, of course it doesn't. As far as fitting this in the case, so basically you just grab your little case contraption that you made, your little circuit, and you line the LED up with the 3mm hole that you've drilled. Just line it up. We'll get a small flat bladed screwdriver just to press the LED firmly into the hole. There we go. And now at this point I'll take some medium strength CA to tag that LED into the case so it doesn't come out. Put a drop underneath the battery case to affix the battery case in there. And as far as the mercury switch goes, I find just having it in this configuration with my specific build here, I like having it just off center of the center. Here would have been the center rib here. Just having it a little bit off center, and that allows the knob to come on maybe at about 10-15 degrees off center, just basically right around where the gas valve is cracking open. And like I said, then the LED will be on solid all the way from high. This is the high position, all the way down to low. And one safety thing you might want to do is after this sets up, after the glue sets up, maybe encapsulate the mercury switch in silicone sealant. Just in the off chance that little glass vial ever breaks, the silicone sealant encapsulation will prevent that mercury from contaminating anything. This is a food appliance, a cooking appliance, and I don't have to tell people the danger of mercury. And that would be the one thing, if you're at all apprehensive about having a little mercury switch around a cooking appliance, then this is not the project for you. There is one other method you could use. This is a micro switch. This is actually a pretty big one. You'd need a smaller one than this with one of these little arms on them, and you could have that in the knob to act as your switch. And then on your back bezel, you'd have to have a little ramp, so the micro switch would ride up on the ramp when you turn the knob and close the circuit, and then when you turn the knob back to vertical, it rides down the ramp and opens up and turns off the light. So a lot of work if you do it this way, but that would be one way you could get around not using a mercury switch. So I'm just going to glue these in here, and we'll go out to the barbecue to see what they look like. But I hope it's a super little easy project. Anyone can do it if you've just got some basic soldering skills, and you can drill a hole and maybe cut out a plastic rib. And it sure has helped me. I bet you it's helped me at least a dozen times. Like I said, pretty absent-minded, or maybe it's just too many wobbly pops during barbecue season. Anyways, that's all there is to it. Super simple little project. Okay, so we're out at the old grill here, and I've got all the new, or not new, but modified LED lit barbecue knobs on. And I said inside they come on maybe around at 10 degrees now. It's more like about, 40, 45. They'll kind of flicker. That's just the mercury bubble bouncing on the contacts. But obviously by the time that's full, it's not going to flicker anymore. I like having the gas valve's probably it's cracking right about there. I've got the gas valve turned off, of course, but the knob valve, that's probably where it's starting to flow gas. And the idea is, you want the lights turned on whenever it's on, and then you can see when each burner is on, and they'll be lit at, these are at low. This is the rotisserie, that's as low as that one goes, but so even at low they're on, and right up to high, and then they shut off, of course, when they're in the vertical. And super easy to see, and it even doesn't, as long as you've got your holes centered and they're all in the same spot in each knob, it doesn't look like a complete hack job, and it looks kind of cool too.